90 miles of tunnel, 6 million cubic yards of chalk, $15 billion, and the end of 10,000 years of separation between England and Europe. The Channel Tunnel is one of the world's greatest engineering achievements, perhaps the single great monument to 20th century civil engineering. This is the story of what goes on inside the Channel Tunnel. For thousands of years, the White Cliffs of Dover have stood as England's main defense against the sea and against the French. Over the centuries, these chalky buttresses have proved impassable. Not since the Ice Age was there a land link between England and France. And not since Norman times, nearly 1,000 years ago, has any army successfully invaded the island of Britain. But things change. The cliffs are no longer England's first line of defense. The London to Dover railway line that once could be brought to a standstill by storms at sea is now half a mile inland. But it is not the train line which moved. It stayed exactly where it was. It was England that got bigger. This is Samphire Hoe, a new nature reserve stretching out into the English Channel. 10 years ago, this did not exist, but digging the Channel Tunnel generated 6 million cubic yards of chalk. They had to put it somewhere, and on the English side, they put it here, at the base of Shakespeare Cliff. Today, these windswept dunes are the main visible legacy of the thousands of men and women who built the Channel Tunnel. The tunnel itself remains in darkness, hidden from the public eye. Richard Dance is the maintenance manager on the English side of the channel. He was only 22 when he signed up as a tunneler back in 1987, when digging was just beginning. He was one of the few who stayed on when the construction was complete, and now he knows the tunnel better than most.
This one's a service tunnel, which is in between the two main running tunnels. We're still underground at the moment. It's about 7 or 8 kilometres before we start going under the sea. We're actually travelling now from the Cheriton terminal underground to Shakespeare Cliff, where the marine side of the tunnel was. They started to dig, where they dropped the shafts and the boring machines started to bore towards France, and also they dropped some more boring machines which bored towards the Cheriton terminal. You could only drive at 50 kilometres an hour with the lights off, 30 kilometres an hour with the lights on.
In the Channel Tunnel, lights on means someone is working in that section of the tunnel, and traveling speeds are restricted. If the lights are off, the vehicles are permitted to increase their speed. There are in fact 3 tunnels, 2 main running tunnels and 1 service tunnel. The northern tunnel carries trains running from England to France. The southern tunnel carries trains running the other way. The service tunnel is smaller and lies between the 2 running tunnels. It is the key to the design of the whole complex because it is both an escape route in the event of an accident and it provides access for maintenance work. Cars can therefore drive from England to France, but mostly there are no ordinary cars.
You've got a guidance system on the vehicle which actually guides the vehicle along, so you can drive it virtually hands-free. There's two cables buried in the road, and the vehicle tracks the two cables and alters the steering accordingly. All you do is operate the foot pedals, stop and go. The rest of it's all automated. We're now in an unlit section, so we can speed up a little bit to 50.
The service tunnel is connected to the running tunnels by a series of cross passages every 382 yards. The running tunnels themselves are connected to a further series of passages called piston relief ducts, which allow air to move between the two running tunnels. The service tunnel is not open to the public. In fact, it is not open at all. The service tunnel is kept airtight and pressurized. There are several reasons for this. The main one is that the service tunnel is the primary escape route for passengers in the event of an accident. Keeping it at a higher pressure than the running tunnels ensures that in the event of an accident, smoke and other
You go back to a round tunnel, and this part of the tunnel was dug by hand. It wasn't dug by a boring machine. The service tunnels now move from in between the running tunnels, drop down and come alongside the running tunnels, and it comes up and it finishes on the left-hand side of the two running tunnels as you exit.
In France, there was no convenient cliff to cut into. Before drilling could commence, they had to dig a huge access shaft at Sangatte. The boring machines were then lowered into the hole. It was hard work. The tunnel leaked. Men would spend days and weeks soaked in icy seawater. Each tunnel boring machine was a factory. The rotating heads cut away at the chalk. Hydraulic pistons pushed the machine forward. Just behind the cutting head, precast tunnel linings were slotted into place. The waste was taken back to shore on trains. At 2 points under the sea, they built huge caverns to allow trains to pass from one running tunnel to the other. These so-called crossover caverns are considered by many to be the greatest achievement of the tunnel builders. The English crossover cavern is 7 miles out to sea. The service tunnel boring machine was some distance ahead of the running tunnel machines. When it reached the site of the crossover cavern, 60 yards below the ocean floor, the service tunnel machine turned down and out to one side. From there, the tunnelers dug a series of access shafts to what would become the crossover cavern. There they began to drill by hand. First they cleared the top section, then the 2 side sections, and finally the 2 tunnels. By the time the larger boring machines arrived, there was a hole in the ground 178 yards long and 16 yards deep. With tunneling going at record speeds, the tunnelers were able to take time out to watch the 2 running tunnel boring machines break through into the crossover cavern en route to France. For the contractors, the crossover cavern offered the only opportunity to see the whole tunnel boring machine in action. At peak production, the machines were more than 300 yards long. Mostly, the crossover caverns look like 2 tunnels because a retractable wall runs down the middle and separates the north tunnel from the south. But when the wall is pulled back, it is possible for the train in the north tunnel to cross to the south tunnel. At the French cavern, it can then cross back again. In this way, the tunnel can be divided into 6 sections, and any one section can be isolated for maintenance work. To support the cavern walls, the engineers drilled pins deep into the chalk. They then allowed the roof to move in a little, monitoring it closely. When the walls had relaxed a little, they were covered with waterproof lining and sprayed with concrete. The tunnel boring machines, or TBMs, meanwhile moved through and continued on their way to France.
They're through. Hey! There's the handshake we've all been waiting for, Mr. Fag and Mr. Cosette.
In all, 11 tunnel boring machines drilled the Channel Tunnel. When construction ended, they suffered various fates. A couple were sold and others were broken down for scrap. One dug its own grave deep beneath the sea. Others became corporate trophies put on display outside the Eurotunnel offices. And this one remains forlorn and forgotten beside the highway in Folkestone. It is a potent reminder that digging the hole is only half the job. The real challenge was to turn it into a profitable transport system. It could not be any old transport system. It had to be the best. Already the tunnel company was burdened by debt, and if the debt was ever to be paid, the tunnel system had to be first class. It was relatively easy to link the tunnels into the British and French mainline railway systems. The train journey from London to Paris or Brussels now takes about 3 hours. It was much harder and a much steeper learning curve to create the shuttle systems for carrying cars and trucks to and from Folkestone. Although it is the tunnel which receives the most praise and public attention, the car terminals at either end of the tunnel also represent a significant advance in transport design and technologies. This is the UK terminal, early on in construction. The terminals were designed in tandem with the design of the carriages that were to carry the cars, and the designers had many things in mind, from security to access to the motorway. Most important was speed. For the key to the operation was that cars and trucks and buses would be able to drive onto and off the shuttle trains. Total journey time, including loading and unloading, had to be kept to less than 1 hour if the shuttle was to compete with the many cross-channel ferries. This meant two things: specially designed rolling stock and a special platform system at the terminals. Without these, the tunnel would not be able to compete effectively. From his position at the Traffic Control Center above Folkestone Terminal, the traffic controller is responsible for making sure cars get on and off the shuttle as fast as possible.
I'll be going from platform 8.
The job sounds simple. Line up the cars and get them on as quickly as you can. Mostly it works. 92% of Channel Tunnel shuttles run on time. But the system is controversial. Passengers stay in the cars during the crossing. They have little to do and less to see. In the event of an accident, there is no easy way out of the cabins. If, for example, there were to be a fire, passengers would first have to get out of their cars, then walk down the stairs inside the shuttle, then out into the tunnel, which they would have to walk through in the dark to find a cross passage. Not easy in a tunnel filling up with smoke. The different trains travel at different speeds. Passenger trains travel at 100 miles per hour. Freight trains at 60 miles per hour, and passenger shuttles at 90 miles per hour. There should always be a 3-mile or 4-minute gap between the front of one train and the back of the one ahead. In any case, there should be no more than 5 trains in either running tunnel at one time. The journey time, platform to platform, is 35 minutes. It takes Gary Parker and Victoria Bridges the same time to travel the 3 miles from their home to London's Waterloo Station, where they're about to take the train to Paris. Gary and Victoria may not know it, but they are living out a centuries-old dream. Since Roman times, Europe's political leaders have wanted a tunnel linking England and France. For some, the motivation was commercial. For others, like Napoleon, the motivation was more of a geopolitical nature. Following World War II, it was again trade that dominated people's thinking. In 1973, Britain finally joined the European Economic Community, the EEC, and the Conservative government pressed ahead with a publicly funded tunnel. 2,000 yards of this tunnel were dug, designed and built by many of the same people who later worked on the Channel Tunnel we know today. But that attempt met funding problems. A new Labour government came into power in 1974 and almost immediately pulled the plug on the tunnel. The main reason was spiraling costs. It was to prove a salutary lesson. In the 10 years that followed, little changed in the design of the tunnel. What did change was the method of funding. New studies suggested it was possible to build a privately financed tunnel to be paid for out of future revenues. In 1985, the British and French governments called for bids from companies wishing to build and then to own the Channel Tunnel. And so Eurotunnel came into being. From the start, the company has marked itself out as a determinedly Anglo-French operation. From time to time, cultural differences do show themselves. At Waterloo Station, Gary and Victoria begin their journey.
5 to 9.
We're off. Just
We're off.
right on time. You can see all the way down to Croydon.
Oh, yeah.
Ooh, yeah, it's really good.
Go past your house.
Do you think it goes this slowly all the way?
No, just to get out of London and go a bit faster, and then faster still when you get to the French side.
It goes faster in France, doesn't it? Yeah.
Progress on England's old train lines is slow. Some of these tracks were first laid more than 150 years ago. A new line from Folkestone to London is now being built, due for completion in 2003.
Ladies and gentlemen, in a few moments we will enter the Channel Tunnel. Transit time should be about 20 minutes. Thank you.
It is only when they reach the tunnel that the train really starts to pick up speed.
Looks like we're going downhill.
Yeah.
Victoria is right, they are going downhill. When they designed the tunnel, the contractors were determined to stay within the band of chalk known as the chalk marl. It is the easiest to drill through and the most stable. As a consequence, the tunnel winds its way across the channel, side to side and up and down. There are 3 low points in the tunnel which act as drainage points for water coming in.
I hope this tunnel doesn't leak.
Have a guess.
It comes as a surprise to many that the tunnel leaks. But it is deliberate. If it did not leak, water pressure would build up unbearably in the rock surrounding the tunnel. The UK pumping station is 45 yards below the bottom of the sea. Above that is another 60 yards of water. Both the rock and the tunnel linings are porous, and water seeps through and falls down the back of the tunnel linings. It gathers in a specially built gully beneath the rails, and gravity pulls it down to the pumping stations. Every day they pump out more than 90,000 gallons of water. They don't pump air into the running tunnels. For that, the design relies on the trains to pull in air. Any moving object creates a flow of air behind it, especially trains. In the tunnels, this could cause pressure buildup. To prevent this, and to allow air to move between the 2 running tunnels, the contractors built a second series of connecting tunnels. Unlike the cross passages, these piston relief ducts are not sealed off. Air moves freely between the tunnels. The same is not true of the service tunnel, which for safety reasons is sealed off and kept at a pressure 1 atmosphere higher than in the running tunnels. This is Sangatte in France, and this is the shaft into which they originally lowered the tunnel boring machines. Now it has other uses. These huge fans suck in air. The air is pushed through these pipes along this weathered ducting, down the shaft, and into the pressurized service tunnel. We can calculate the exact volume of each tunnel. The service tunnel is 30 miles long and 16 feet in diameter. To keep the air pressure at 1 atmosphere above that in the running tunnels, air must be pumped in at a rate of 220 cubic yards per second. There is a similar set of machines at the foot of Shakespeare Cliff in England.
Mesdames et messieurs, votre attention s'il vous plaît. C'est votre chef de proie.
It's France.
Gary and Victoria emerge in France.
De 15 minutes. Si vous avez des problèmes de correspondance, nous nous excusons pour tout.
Their journey, like all other journeys through the tunnel, has been controlled and monitored from here, the Rail Control Center underground at Folkestone. Michael Bent is one of the managers.
The RTM is the railway controller of trains, and it is controlled by computers. If everything is in its right order, on its right platform, at its right time for departing, it can be overridden at any time by the RTM controller on duty, and he can input manually dialogue commands for trains to start, go, stop, or alter platforms or alter routes. If this person did nothing during an 8-hour shift, it means that all her systems have worked perfectly well. If he or she is busy, it's because something is going wrong or needs altering somewhere in the tunnel.
This wall represents the entire tunnel system. There are several types of train going through, and each has a different number. 9,000 represents a passenger train between London and Paris or Brussels. 7,000 represents a freight shuttle. 6,000, by contrast, represents a passenger shuttle. Passenger shuttle 6368 has just left platform 7 in Folkestone. The orange light tells Michael what will happen unless he does something to stop it. With no counter-command, passenger shuttle 6368 has moved as far as Shakespeare Cliff. A few minutes later, it has reached the crossover cavern. The crossover caverns are almost always closed. At night, one section of the running tunnel may be closed off for maintenance work. Passengers would hardly know what had happened. Only the most seasoned traveler might notice that trains travel marginally slower when switching tracks. Within the service tunnel, the only evidence of a train going by is the slight increase in sound above the noise of the fans. But the control center doesn't only control the trains. Just to get the lights turned on takes a radio call from Richard back to the TCC Underground in Folkestone.
Everything that is fixed equipment is controlled from this position. If a driver, for example, wanted running tunnel lights to be switched on, he would ring up this controller on this position and ask for the running tunnel lights to be lit in a certain position of the tunnel, and they would be lit by this controller who is sat here.
Mostly, the tunnel is kept in complete darkness. The light should only be on if there is someone working in that section of the tunnel.
It's the fire brigade.
Richard heads for the exit.
We're just about approaching the UK portal airlock. It's a double set of doors, which is designed really so as to keep the service tunnel at a slightly higher pressure than the running tunnels, which creates a safe haven in the event of any incidents in the running tunnels. So therefore what we'll do now, we'll come up, get permission to enter the airlock. The doors are open, we enter the airlock, the doors are shut behind us, then the doors in front will open and let us out into the fresh air.
It takes another radio call to get the doors open.
FDC, this is CAT 63. We're now at the UK airlock. Can we please exit the service tunnel, over?
Okay, no problem, I'll call him straight away, FDC, yeah.
Thanks very much, over and out.
The airlock system is slow and tedious, but it never fails to remind Richard how important safety was and is.
If you worked in a safe manner and you looked after yourself, you were safe. If you took chances, then obviously that's when things happen.
11 men died building the tunnel, 2 on the French side and 9 on the UK side. To date, no one has died running it, but the danger is always there, and Eurotunnel knows that everyone must be vigilant. With so many cars and people going through the tunnel, fire is a particular hazard. The fire brigade patrols the tunnel 24 hours a day. At no time are they more than 20 minutes traveling time from any point in the tunnel. Sometimes that is not enough. This man was on the shuttle in November 1996 when the only accident to date happened.
But the car was absolutely full of smoke and poisonous fumes, and it was just a miracle that we all managed to get out in one piece. Like, I'll say another 6 minutes or so, we'd have all been carried out, well, not all of us, I'll say, but one or two of us would have been carried out in bags.
The November 1996 disaster was a serious setback for Eurotunnel. It started on a freight shuttle a few miles out under the sea en route from France to England. Unlike the passenger shuttles, freight shuttles have open sides. When a fire starts on one of the trucks, there is no way to contain either the fire or the smoke. In the ensuing confusion, many of the safety procedures failed. The driver was unable to decouple the trains. Fans designed to clear the smoke were not switched on, allowing smoke to be drawn back to the front restaurant car. 34 people were brought out, and 8 taken to the hospital, suffering from smoke inhalation. Fortunately, nobody was killed.
Within, what, minute, 2 minutes, we were all in the alleyway, on the ground, trying to breathe.
If you can see that, all this black area is apparently the smoke that's been inhaled into the lungs.
Well, I was afraid, and I think they all were afraid.
You only go just inside.
Fire crews and freight drivers were sent to the wrong door of the service tunnel.
Ceiling.
It took over 400 firemen 6 hours to bring the fire under control.
We're extending this line. Yeah. So we can move a little way up that way to the fire, okay? Come round. In a minute. Yes, in a minute.
The heat in the tunnel was so intense that parts of the train were welded to the track.
In the 20 years I've been in, it's certainly something I've never experienced before. My fire helmet, although it's actually intact, the actual substantial part of it, when you actually have a look inside, you can see where it's actually started to blister up.
Were you aware of that at the time you were wearing it?
I was wearing it at the time, yeah.
The section of the tunnel in which the fire happened was closed for repairs for 6 months. It is estimated to have cost Eurotunnel $420 million in lost income. The repairs cost over $110 million. The British government report on the fire was critical of Eurotunnel, although it considered that effective action by firefighters and others made the event much less serious than it might have otherwise been. A French judicial inquiry subsequently concluded that the fire had been started deliberately, but the culprits have not been caught. Despite the controversy over open-sided freight shuttles, Eurotunnel continues to use them. If anything, the new shuttles are even more open-sided than before. This new railroad car is about to come into service. 3 years on at the maintenance yards in northern France, the memories of the 1996 fire linger on. The Eurostar train reaches its top speed of 225 miles per hour near Lille in northern France. To keep the ride smooth, shuttles and trains undergo constant maintenance and replacement programs. Here at the maintenance sheds at the French terminal, this locomotive has come in for its routine service. The sheds are long enough to accommodate an entire shuttle train. The shuttles always move clockwise, and the tight turning circles at each terminal mean the wheels wear out relatively quickly. This looks like a bunch of used metal, but each of these chassis is in fact some very expensive technology. Just 3 hours after leaving London, Gary and Victoria arrive in Paris. They have plenty of time for sightseeing before lunch. As the European Union moves toward a single political and economic entity, border controls have disappeared between some member states, but they are still firmly in place between Britain and France. This has one odd effect in that the border between the two countries now occurs at a range of different places. Passport control for the mainline services is at Waterloo Station in London, but the British Customs is at the French terminal near Calais. The tunnel is an obvious target for smugglers. Although the main concern for customs officials is illegal drugs, bootlegging of tobacco and alcohol is an increasing problem. British taxes on goods such as cigarettes are much higher than in Europe. Customs officers use a mixture of sound intelligence and gut instinct in deciding which cars to search. But such is the volume of traffic that this can never be enough. Mark Witz is a British customs officer working in France.
The staff will say that 95% of the vehicles travelling, of the cars this is, travelling between the hours of 2 o'clock and 6 o'clock approximately, will be big-time bootleggers with at least 50 kilos of tobacco or the equivalent amount of cigarettes. So basically every vehicle you could stop would have a considerable quantity of contraband.
This dog, Catherine, has been trained to look for illegal drugs. In this car, she's looking for heroin, amphetamines, ecstasy, and marijuana. The most common find is marijuana, but big hauls of both cocaine and heroin have also been known. A small car like this is also relatively easy to search, and it doesn't take long. But a coach or a bus can take up to 2 or 3 hours, as the officers and dogs go meticulously through each section of the vehicle. Drug searches are tense enough. Deborah doesn't want to upset the car owner by having her dog dirty the seats. On the average at this checkpoint, they will search 5 or 6 cars an hour, 24 hours a day, 365 days a year. And still, most drugs get through. Nothing today. In recent months, customs officials here claim to have recovered cocaine worth more than $10 million. But the tunnel hasn't made their job any easier.
I'd have to say it's made it harder. First of all, it's another point of entry that we have to man. As opposed to the ports, we have no manifests for vehicles, so no advance information, so it makes it more difficult to target specific vehicles. And the other thing, of course, is that a considerable amount of time is wasted by our staff having to travel from the UK to France in order to begin their shift. It takes approximately 2.5 hours a day return just to get to and from the place of work. So that's obviously very expensive to the department as well.
Customs may not like it, but the customers do. The Channel Tunnel means that cars can cross between France and England in safety and comfort, no matter what the weather. For Gary and Victoria, the tunnel has made a day trip to Paris cheap, comfortable, and enjoyable. Will there be a new tunnel? Eurotunnel delivered a feasibility study in December 1999. As before, there is much debate whether this should be a road or a rail tunnel. Probably we shall all have to wait some years to find out which it'll be. One thing is for sure, we know it can be done.